All right, welcome to the Explainer. Today, we're going to pull back the curtain on a piece of engineering that's, well, it's probably right in front of you every day, but you never really see it. We're talking about the platform screen door.
You know that gap, right? The one between the platform and the train? It's always there, and on a busy day, it can be, well, a little nerve-wracking. It's a genuine safety issue. But it turns out there's a super sophisticated solution hiding right there in plain sight.
So what are we talking about? Platform screen doors, or PSDs. I mean, at its heart, it's a pretty simple idea, right? It's just a barrier. But this system is so much more than that. It's more like the platform's invisible shield. A high-tech guardian angel that does way more than just open and close.
Okay, so here's how we're going to break this down. First up, we'll look at why these doors are such a big deal, the invisible shield part. Then, we'll get into the brawn, the heavy-duty mechanics of it all. After that, we'll check out the brains, the smarts behind the operation, and finally, we'll see how it all comes together as the ultimate safety net.
All right, first up, the platform's invisible shield. So, what's this shield really protecting us from? It's not just about stopping people from falling onto the tracks, though that's obviously huge. It's about creating a totally controlled, totally safe environment for the whole platform.
Yeah, job number one is safety, for sure. That physical barrier is just non-negotiable. But these systems are also designed to make the whole station experience better. They cut down on that deafening roar from the tunnel, they help keep the platform's climate under control, and you know what? By helping people flow smoothly, they actually keep the trains running on time. It's a win-win-win. Okay, let's move on to the brawn of the operation. We're talking about the sheer physical strength and incredible precision of the doors themselves. I mean, this is the hardware that has to work perfectly, day in and day out, millions and millions of times a year.
And when I say built to last, I mean it. These things are designed to have a minimum life of 30 years. 30! To pull that off, the main structure is made from hot-dip galvanized carbon steel. It's specifically chosen to take a beating for decades without giving up.
And get this, it's not just one kind of door. It's more like a whole door family, each with a specific job. You've got your main automatic sliding doors, the ASDs for us passengers. Then you've got the emergency escape doors, the EEDs, with those panic bars for a quick getaway if needed. And finally, the platform end doors, or PEDs, that are just for staff.
And the strength? Wow. The structure is engineered to handle a crowd load of 3,000 newtons per meter. Now what does that mean? It means you can push a whole crowd of people against it and it won't even budge. It's designed so that even at the craziest rush hour, that barrier is an absolute rock.
So how do these massive, heavy doors glide open and close so smoothly? Well, the magic is in this surprisingly simple system. You've got a powerful DC brushless motor that gets a command. That motor turns a pulley, which moves a super tough toothed belt. And that belt makes sure both sides of the door move together, perfectly in sync. It's elegant, it's strong, and it just works.
All right, we've seen the brawn, now let's look at the brains. We're going behind the scenes to explore the system's central nervous system. This is the complex web of signals, controls, and sensors that makes all that heavy-duty hardware so incredibly smart.
So the whole thing runs on a really clear chain of command. Think of it like a hierarchy. At the very top, you've got the PSC. That's the central brain for the entire platform. It sends commands down to the LCPs, the local controllers. And those local controllers then talk to the DCUs, which are the individual brains for each and every door.
And a system like this has to be ridiculously reliable. I mean, check this out. It's engineered for a mean time between failures of over 40,000 hours. Let that sink in. That means it's designed to run nonstop for more than 4.5 years without a major breakdown. That's just incredible.
So how is that even possible? Well, a big part of it is that every single door has its own little brain. That door control unit, the DCU, it's not just a dumb on-off switch. No way. It's a programmable controller that's constantly getting feedback, pulse signals, from the motor, so it knows exactly where the door is at any given millisecond.
And that kind of intelligence leads to some really cool safety features. Like check out its obstruction detection. It doesn't need to physically bump into your backpack to know something's wrong. Instead, it uses this clever distance over time idea. It knows precisely how long it should take to close. If it starts taking longer, even a little bit, it instantly knows something's in the way and reopens.
But the safety logic goes even deeper. What if something keeps blocking it? Well, if the system detects an obstruction 3 times in a row, it doesn't just keep trying to close. It says, nope, something's not right here. It defaults to safety mode, opens the doors all the way, and sounds an alarm.
It's all about prioritizing people over schedules.
Okay, so that covers normal operation. But what about when things go, well, really wrong? A power outage, a big emergency. This is where we see the system's ultimate safety net. It's built for a bad day, with layers upon layers of backups. Yeah, this is the break glass in case of emergency plan. You've got manual release handles on the trackside, you've got panic bars on all the emergency doors, there are big red emergency stop buttons for staff, and even bypass switches to isolate a single door that's acting up. And of course, the whole thing is on a backup power supply so it keeps working even if the lights go out.
But wait a minute. Even with all of that, there's still one tiny, critical space that needs watching. You know what I'm talking about? That gap. The little void between the closed train door and the closed platform door. It might be small, but it's probably the most dangerous spot on the whole platform.
So how do you protect that space? Well, the system has one last trick up its sleeve: a laser shield. It's this 980 nanometer laser beam, totally invisible to us, that shoots along the entire length of the gap. It creates this invisible tripwire, a laser grid, right where you need it most.
And if anything breaks that beam, a person's foot, a dropped bag, anything at all, it does more than just sound an alarm. It instantly sends a critical, hardwired signal straight to the train's brain.
And here it is, the ultimate safety guarantee. That signal physically cuts off the train's safety circuit. It makes it impossible for the train to move. The train is literally forbidden from leaving the station until whatever broke that beam is cleared and the laser shield is whole again.
So when you put it all together, from steel beams to laser beams, what you have is this unsung hero. It's this amazing blend of raw mechanical power and incredibly sophisticated digital smarts. And every single part of it is dedicated to one simple goal: keeping you safe.
It's a system that's so good at its job, so reliable, that you're never even supposed to notice it's there. And it kind of makes you wonder, doesn't it? What other hidden engineering marvels are out there, just hiding in plain sight, quietly making our world go round?